Hello there, and welcome to the fourth part in this series on Unity fundamentals, especially designed for the students of Saturday Academy. I am your instructor, Will Patillo, and in this video we're going to start creating some actual game mechanics for our game. And I'm going to start out by having this button actually open this doorway. And for this, as well as many other things in this game, we're going to be using something called UnityEvents. It is a feature that isn't really covered in a lot of other tutorials, and I find it incredibly useful in separating the programming from design and creating some really flexible levels. So we'll get right into this. Right now we have our button that detects trigger entries and exits, but doesn't actually do anything when those happen. So let's address that right now. So I'm going to create a new variable, and it's going to be exposed in the inspector. So I'm going to use a serialized field here so it shows up, and I'm going to create a Unity event, and I'm going to call this on contact. All right. And also, I'm not really using this on trigger exit anymore. I'll cut that. Now, one thing you'll see right off the bat is there is a error that shows up. It doesn't know what Unity event is, and that's because I'm missing a library. So right at the top here, I'll say using Unity engine.events, and that will make this error go away. So now I have this on contact right here, and this will show up in the inspector window as this little box right here. And nice thing about these is I can click the plus and add things to it, as many as I like, and they can interact with the scene. So when the contact occurs, I drag in the door, and actually just describe what I want to have happen. So this door, right at the top, there's this checkbox that says whether the game object is enabled. And if I untick that, then it disappears. So I'm going to do that through the programming, or through the level design. So in this onContact event, I drag in the door, and then I click this drop-down menu, and I select the game object, and I set active, and have this unticked. That's basically exactly the same as ticking that manually. And then, so that this actually gets called in my code on this onTriggerEnter, I just write in onContact.invoke. So when this onTriggerEnter happens, this line of code will execute, which will cause this event to occur, which will make the door disappear. So let's try that right now. I run the game, I walk over to the button, and the door is gone, and now I can escape the room. Great. Get rid of that. In addition to having this door disappear, after a few seconds, I would like this door to come back, so that so the door just isn't always gone. So for that, that's a timed event, and I'm going to make that separate from this contact event. Create a new script, C# contact event. Oh, that's not the name I wanted. I want a countdown event. And because I didn't name it right the first time when I open this up, I'm going to need to change it here. So countdown event. Okay, and if you want to be able to attach scripts to objects, the name that you use here has to match the class name here. It'll still compile if they don't match, but you won't be able to attach them to game objects and other reasons as well. Alright, so for this countdown event, I'm going to have a public void begin, and so this is what's going to be called when the countdown event starts, and then something needs to happen when the countdown is over, so I'll create its own method for that. I'll say private void end, And I want this begin method to call the end method after a set amount of time. So to introduce a delay, the simplest way to do that is to just type in invoke with nothing before it. And this takes two arguments. First, the name of the method that I want to call, and then second, the amount of time until that happens. Now, I could put a number here, but that's not very flexible, so I'm just going to go right off and create serialize field float duration. All right, and then I use this duration variable here instead of 1. Now, just to show how this works, I'm going to put in a debug log right here and say end method reached. Now, on this button, I'm going to attach this countdown event. I'll give it 3 seconds. And so that this actually gets called, I'm going to add another item right here to this contact event and drag in the button object. Take this drop-down list, I find this countdown event, and click begin. So now let's see what happens. So when I touch the button, in addition to removing the door, it will also invoke this countdown event.begin, which will then wait 3 seconds and play the end. And actually I didn't really see that show up in the console. Let's do this again. 1,000, 2, 1,000, 3, 1,000, and the end method is reached. All right, so now when we get to that, instead of printing to the console, we want something to happen. So I'm going to create another serialized field, UnityEvents, and on end. And in this on end, I just type in on end dot invoke. And I can get rid of this console message. Okay, so that causes, oh right, I forgot the library. Using Unity engine dot events. And since I'm here, I can also get rid of the system collections generic and also systems.collections. I'm not going to need either of those just now. And in this countdown event, on this on end right here, add the plus, bring in the door, set game object, set active to true. So the full flow right here is when I touch the button, it causes the onTrigger enter method to fire, which then invokes onContact, which disables the door and also starts this countdown. After 3 seconds, it calls the end method, which invokes onEnd, which then re-enables the door. And then after 3 seconds, the door comes back and I can't get through. Now that may seem a little bit of a roundabout method to just make this appear and disappear. I mean, I could have, in this contact event, just made it a door open close script and had a onTrigger enter and then have the door disabled directly right in the script and then call a 3-second invoke and have the door reappear there and just all have it in one place. But the nice thing about doing it this way is these are extremely general purpose scripts. This contact event and this countdown, like I can use this for anything where I want something to happen when you enter an object, and I can use countdown event whenever I need something to happen after a timer, and these have nothing to do with, these don't know anything about buttons or doors. I can just use them wherever. So that little bit of extra complexity can get you quite a bit, and we're going to be exploring that as we build out this project. I'd like to have a little visual effect where this button looks like it's being pressed down, like I'm actually stepping on it and depressing the button. So I'm going to need something that will move this button from here when it is up down to say like here or so when it's been stepped on. So for that, I'm going to create a new script C# called fixed point movement. Okay, and create a serialized field here, and this takes in a transform, and this is going to be the thing that we're moving. And also copy that, paste, and now I have an array of transforms for the locations that it moves between. Next, I'm going to create a public method. It doesn't return anything, so it's a void, and call this jump to position, and int index. I'll explain what that's for shortly. And then we're going to have this toMove.position equals locations index dot position. Copy this line and do the same thing for rotation. So next on this button, I'm going to create a couple more empty game objects, and I'm going to call this the up position, and another one for the down position. And actually I'm going to put these both, control, and then select them, make sure they're both in the escape room. Also, I'm going to make sure that they're aligned with the button for now. So I copy this component on the transform, which with this little gear icon, copy component. Select both of these. If I click one, press Control, click the other, and then click Paste Component Values. Make sure they are right there. And also, to clean things a little bit, I'm going to create an empty object. I'm going to call this a button container. Just leave that empty, and also place it where the button is. And I'm going to take all three of these and put these inside the button container. That way it's not cluttering up this hierarchy. Now in this button, I'm going to take this fixed point movement script, place it in there, and the item to move is the button itself. It moves itself, and its location, I have this array size 2, and I have the up position and the down position. Now I'm going to make sure they're not in exactly the same place, so I'm going to just take this down position and move it down by -0.5. Actually, I'll go with -0.3 to start with. Okay, now in this button, when it's contacted, pass in itself, and press the fixed point movement, jump to position, and I'm going to take the first element in the array here, number 1. And if this isn't quite making sense, don't worry about that. It'll all become clear once you see it. Fixed point movement, jump to position, and 0. So how this is going to work is when this contact event occurs, the jump to position method in fixed point movement is going to execute, and it's going to be passed the number 1. And if we look at that, receives index 1, and its transform, the toMove transform, which remember is the button, its position is going to be changed so that it equals that of the first item in this locations array. So that is, its position is going to equal that of this down position, which is a little bit lower. And rotation as well, although we're not really changing anything here. And then once the countdown finishes, then it's going to move back so that this button's transform position, all these values, match that of the up position, or the 0th item in this array right here. So let's see that in action. Okay, so I touch the button, and it's just moved down to its down position. When the timer runs out, it comes back up. Let's just hit that again, and there it goes. All right, so this, I'm going to stop for a moment and just show you some other uses of this fixed point movement, and this is where we're going to start seeing the benefit of this modular approach that we've been taking to the design. So I'm going to create a teleport system. So I can create a new 3D object and call it, just have a cube right here, and I'm going to just call this, actually before that, create an empty. It's at the same position as the cube. Put this underneath it, and I'm going to call this a teleport system. Okay, and okay, that's over here. I'm going to bring it into the room so I can use it quickly. Bring it over here. I'm also going to create a new material for this. Just say create material. I'm going to call this blue. And I'm set its red and green values to 0. Blue stays at 255. Drop it into that. Okay, so that's one cube. Make it a trigger, and I'm going to give this cube. It's going to give this a contact event, so it can detect those trigger entries. And actually, I'm going to make another cube, move that over here, and this also has, since I duplicated it, it already has a contact event. And now in this one, I'm going to add in this fixed point movement script, and this time, instead of moving itself, it's going to move the player. And I'll just give it one location that it can go to, and that is the other cube. Do the same thing for this cube. Set in a fixed point movement, move the player, give one possible location it can go to, and set that to the 0th cube, like that. Alright, now we need to actually have that occur, so click on contact, pass in itself, and use this fixed point movement, jump to position 0, so that's going to be this 0th element of the array, and do the same thing over here. So pass in itself for the on contact, fixed point movement, jump to position 0. Alright, so now if I play this scene and I step over here, okay, there's a little bit of a bug right here. What's happening right now is I touch this one and I immediately teleport over to this, but when I teleport here, I execute the trigger, and that causes this on contact event to occur, which sends me back here, and then back here, and back here, and back here forever, and I just keep teleporting every single frame, and it's kind of impossible to escape. So let's go ahead and fix that. Create a empty game object, and I'm going to call this a landing point. And take this landing point, and I'm going to move it back a little. There we go, like that. And do the same thing here. Create empty landing point, and move that back a little as well. So now we can actually see these teleports without that weird problem that we were facing. Okay. Oh, right. And also forgot, instead of sending it to the other cube, I need to actually send the player to the other cube's landing point. So again, this cube location is that landing point, this cube location is this landing point. Alright, try that again. So move over here, and now I've jumped over to this this button. I go here, now I'm at this one. And if I keep moving forward, then I'll just teleport around. If I want the teleport to go somewhere else, all I have to do is just take this cube and say, like, I put it outside of the room, and now I'm teleporting to a different location. Now I'm outside the room, now I'm back in. Now, one thing is you may be using lots of these teleport systems in your game. Actually, the same thing goes for the buttons. And duplicating works, but the problem is if you decide later that you're going to make slight tweaks to how it works, you have to go and find every instance of it and make the changes to all of them. So to prevent that and make editing multiple things at once a lot easier, we're going to create a prefab. So I'm going to start with this teleport system, and alright, I'm going to create a new folder. Call this prefabs, and open that up, and just take this teleport system right from the scene and drag it into this folder, and that creates a prefab, and that makes this become a prefab. Do the same thing for this button container. So I'm going to just drag this in to prefabs, and there we go. So the benefit that this gets is if I take this teleport system and drag it into the scene, say move this over here. Actually, I'll maybe move this one here so I can reach it. Now this one is going to work the same as the other one. So if I go to this new teleport system, that's because I need to pass in set the player as this toMove object. Okay, so go here, and I'm sent outside. I set these a little too low. I need to raise this teleport system up a little, because this teleport system is a little bit above the ground. So I'm going to take this, just copy that value, and paste that in there. Okay. I'll try that once more time. Okay, and now this new teleport system is working like the old one. Now, so far, that's the same thing that I would be able to get just duplicating. The benefit of using a prefab is, let's say I wanted to make the teleports use red buttons instead of blue buttons. I mean, there's tons more possible changes I might want to make to it. And if I had just duplicated them, okay, I could create both of these, and I could take in their materials and pass in the red, but it would only change that teleport system. If, on the other hand, I edit it on the prefab level, then I can change all of them at once. So to edit the prefab, I select the object here, and then I click this little arrow, and that takes me into the Prefab Editor. This is a new feature in Unity 2018. The alternative way to get at the prefab is if you double-click prefab, click the prefab system, and open prefab. That'll get you to the same screen. Prefabs exist in earlier versions of Unity. It just doesn't have quite the same nice interface for working with them. Alright, so now once I'm in this prefab system, I can change the color the same way. I select them both, and I go into Materials folder and drag in my red there. But now you'll see both teleport systems have changed color, not just one of them. So that's the value of using prefabs. It makes multi-editing much more efficient. Alright, so I don't really need teleports just yet in this game. There's not really any purpose to them. So I'm going to delete these for now. But if I want to bring them back later, all I need to do is just drag in the prefab, and there they are. And I just need to make sure that the height is correct before they're used. All right, now have yet another feature of this jump to position and some of the modular code you have is, so far, we're stuck in this third-person view. We're always behind the character. What if we want to have the option of being in a first-person view, as in seeing just out of the eyes of this character? Well, we can do that by creating, first we just need to create, so the way we're going to change points of view is by using that jump to position script. I suppose I can just attach it right here to this camera, this fixed point movement, and have it move itself and give it as many locations as we want to move between. So next we need to create the positions that it jumps between. And so I'm going to create a new empty game object, and I'm going to call this third person view, and I'm going to set its transform so that it's the same as the view that I have now, because I think this current view works pretty well for a third person view. Okay, there, so now it's right where that is. And then I'm also going to create a first person view. And I'll set this rotation to 0, and I'm going to place this one, actually I'll start by placing it right at the center of the character, and then I'm going to move it up a little and then forward some so that it's inside of these little black goggles that the character has. Actually, I'm just going to set the Z onto negative 2.5, Y at 0.475, and X at 0. That should get it right in the center of these goggles right there. Okay, so those are my views. Okay, and now this camera, I can pass in the first person view and the third person view. Okay. And now I need to get some more input that allows that I need some way of triggering this fixed point movement to actually move the camera around. And that's going to be from a key press. So I'm going to go back into this keyboard input script that I had here. This created in, I believe this was the second lesson of the series. If you skip that, here's the code. And I'm going to create a new key code to look for. And I'm just going to call this POV change for point of view change. So I'll need to create a new method, private void detect perspective key press, and it's going to have the same structure as those other methods, key code keys, and it only needs keys, it doesn't need any direction variable here. Since this is kind of similar, I'm going to copy this, just change what I need. Okay, for each key in keys, if that key is pressed, then I'm going to need to actually call that key change. Just take a serialize field, fixed point movement, and let's call this POV. Okay, and then here I'll say POV dot jump to position, and then here I need to actually for now I'll just pass in 1, so I can only go from, this will be a bit limited, but I'll have another way of modifying this. I just want to explain what's going on before I make it more versatile. Alright, so now I have this keyboard input. I have a new options for key presses here. This time, to keep things make things go a little quicker, I'm just going to give one option, and I'm going to use the backspace key. And then I'll drag in the main camera into this POV field, because the camera is what has this fixed point movement, which is what the field was looking for. And that should cause it to, if I press the backspace key, it should move to the first element in the array, which is third person view. So I'm going to actually change this 1 to a 0. I also need to actually make the check here. So I'm going to go down here, detect perspective key pressed, and pass in the POV change key list. Because without this, then this is never being called, which means it's never checking for those keys. So I'm going to run this again. And I've just changed point of view to first person, but if I press it again, then I'm stuck there. But what I would really like is to be able to cycle between different points of view. If I press backspace, then I go from first to third person, and if I press backspace again, I go from third person to first person. And I'm just going to use the same key to cycle between views, rather than having different keys for each view. You could do things differently if you like. So to create that cycling ability, I'm going to expand this fixed point movement script and add in something for cycling. Create a public void cycle position. Doesn't need any arguments because it's always just going to go to the next or back to the beginning of the list if you're at the end. And here, and first I'm going to create a variable here, int current index. So when this cycle position method is called, I'm going to current index plus plus. So plus plus increases whatever value here, increases this by 1. I'll just initialize it to 0. This is implied, and if I just declare an int variable, it'll automatically be set to 0, but this way I'm just being explicit about it, so I know that. So the first time this is called, this is going to go up to 1, then to 2, then to 3, and so on. And then I go jump to position current index, and so now that just goes back to this method. So if if something's at position 0 and I call cycle position, then this number will become 1, and then it'll move to position 1. Now to go back from 1 to 0, then I just need to cycle back. And for that, just put in an if statement. If current index is greater than or equal to the locations dot length. So if it's greater than or equal to the size of this array, then I just set current index back down to 0. So if it's already 1 and there's only 2 elements in the array, I call current index plus plus, it becomes 2. 2 is equal to the length of the array, which is 2, and so this goes back to 0, and so now it's going to jump to the 0th position. Oh, one other element I'm going to add back into this jump position, just a little safety check, is if, say, on that teleport, I told something, like say off on this button container, for example, or this button, I told it to jump to position, say, 5, and there's only 2 points in the array, that would create an out-of-bounds error. I'd be passing in 5, and so it would be looking for the 5th element of this locations array, which doesn't exist. So just to prevent that from happening, I'm going to add in a if index is greater than or equal to locations dot length, then return. Just prevent those errors, and it'll just be invalid. Alright, so a return prevents the rest of the code in that method from executing. And one last thing I'm going to add to this script before I move on is just here at the end of jump to position, I'm going to say current index equals index. So that is, whenever I use this jump to position method, then I'll set current index to whatever was passed in. The reason for this is sometimes jump to position isn't called from cycle position, it's called from other places. It's set via a Unity event. And if current index is not updated, then these could get out of sync, and so cycle position might take you somewhere that's unexpected. So now on this keyboard input, rather than calling jump to position, I'm going to call cycle position, and I don't need to pass any arguments. Okay, so what this does when the perspective key is pressed, so this serialized field allows me to assign the reference, so I don't need to use this get component at the very beginning. So this reference has been assigned, and that goes to this component of the main camera, so that this right here, again, goes to this, and it calls the cycle position method, which will go to the next element of this positions array, and if it's already at the end, it'll go right back to the beginning. So if I run this, and I press backspace, I go to first person view, press backspace again, and I go back here, and oh, one thing that's happening is it's checking for that continuously. To change that on this keyboard input, rather than having input.getKey, type in input.getKey down. Fires whenever the key is pressed. GetKey down only fires on the frame where the key is pressed down, and then will be false when you're just holding. So let's try that again. So press once, and I change point of view, press again, and I'm back here. And I can keep doing that, and I'm changing point of view between first and third person. Now, one other thing you'll notice with this point of view change is that the first time I press backspace, nothing happens. And then after I press backspace again, then the change works fine. This happens every single time, so if I hit play again, and I hit backspace again, nothing happens, and then after that, it works. The reason for that is, if I take a look at this camera here, notice it's because of the order that I placed it in. First person view is in the 0th element, and element 1 is the third person view. Current index always starts at 0. So at the very beginning of the game, I run this, current index is 0, I press backspace, and current index will become 1, and so then it jumps to, and this doesn't execute because it's not longer than the length of the array, and then it's going to jump to position of index 1, which is third person view, which I'm already in. So it isn't that it's doing nothing, it's that it's jumping me to the position that I already am. So it looks like it's doing nothing, and then after that it works normally. So the easiest way to change that is I can just swap these around right here. I put third person view there, and first person view here, and now it works on the first try. Now the one thing I don't particularly like about solutions like this is it's dependent on things that I could very easily get wrong. And getting this right requires knowing how the code works, and if you're working on a project for a long period of time, you're going to forget these things. So I'd like to make it a little less dependent on little details like the order in which I place these transforms. So the way I'm going to deal with that is I'm going to create a start method, private void start, and this is again built-in Unity method, and jump to position. I'll just create another serialize field here. We go int starting index. And instead of a hard-coded value right here, I'll say jump to position starting index. Now this number is exposed right up here, so I don't need to change it in code. So if I put a 1 there, then I'll start in the third-person view. If I place a 0, then I start in first-person view. And if I don't want this to execute at all, I can just add another little if statement right here. If starting index is greater than or equal to 0, then I'll jump to position. And if I put in a negative number here, then it'll just ignore this. So if I don't want any initialization to happen, then I can just put in this -1. Like I want to use this starting index in this camera case, but I might not want it for other things that I used fixed point movement for. So that's why I'm creating this condition here. In the next video, I'm going to start adding a little bit of complexity to this little mini game that we have here. I'm going to add some coins in the room scattered throughout it, and you have to collect them all before the button is unlocked. If you just try to press it right off the bat, then nothing happens until you get all the coins. Then you can press the button. We'll also add a little bit of a color changer to this button so that it creates a bit of a visual cue as to when it's locked and when it isn't. So thank you very much for watching, and I will see you in the next one.